So today we're going to look at an extremely important property in chemistry known as density. All of the objects that you encounter have a certain mass and a certain volume. Talking about each one of those a little bit more, the mass is a measurement of how much matter makes up the object. So different objects are made up out of different amounts of matter. Our mass is just a measurement, a number typically, measured in grams, that represents how much matter is in that object. And then our volume is the space that the object occupies. The object occupies. Right? Every object exists in three-dimensional space. Our volume is our measurement of how much space that is. What our density really is it's just simply a ratio of mass and volume. Right? What's kind of neat about this, what's useful about this to us, is that if we have something that is a consistent object and we know its density, it's going to let us talk about an object from either the mass or volume perspective simultaneously. This U is bothering me a little bit, so I'm going to make it a little bit cleaner. There we go. So we can measure mass and we can measure volume and we can talk about density, but we could also take density and measure the mass of something and automatically know how much volume it's going to occupy, or vice versa. Part of the reason why we can do that is density is what is called an intrinsic property. This is kind of an important part of it. An intrinsic property is something that is based on the identity. And we'll come back to this thought in a few minutes. But because it's based on an identity, anytime we have a substance of a particular identity, it's going to have the same density. So we'll come back and see an example of that in a few minutes. Let's talk about how we can find density and how we represent it. So when we're talking about density, right, we set up here just a ratio of mass to volume, which means that density is always equal to the mass of an object divided by its volume. Typically, again, you'll see the masses are in grams, and you'll see the volumes are in either milliliters or sometimes centimeters cubed, which means that our units for density are usually either grams per centimeter cubed or grams per milliliter. Typically, if it's a solid, we're talking about centimeters cubed. If it's a liquid or a gas, we're talking about grams per milliliters. This idea of a ratio, density being a ratio, is something that should not be overlooked, right? Because density is an intrinsic property, it's based on the identity, that ratio gives us some huge value in more than one way. So, I mean, yeah, we could just kind of figure out density of an object over and over and over again to use it to identify something. But if we know an object is of a certain identity, we can use that fact to go back and forth between these two things. Because this is a ratio, this will always scale up correctly. So what I mean by that is, for example, the density of aluminum is 2.7 grams per centimeter cubed. Well, what that means is that it's 2.7 grams, that every time you have 2.7 grams of mass, you have 1 centimeter cubed of volume. But you could also have 5.4 grams and 2 centimeters cubed, or you could have 8.1 gram and 3 centimeters cubed, or you could have 1.35 grams and 0.5 centimeters cubed. If you know that the substance, I'm going to change colors here to highlight some stuff, but if you know that the substance is aluminum, you know what the mass volume ratio has to be. It has to be 2.7 to 1, which means that if you know one of those measurements, if you know density and mass, it's easy to find out what volume is. So that's actually what's going to be the meat of the rest of this video, is we're going to talk about how we can take this density equation and use it to find mass or volume. I think everybody can kind of follow along with how to find density using mass and volume, right? You just take your mass measurement and divide it by your volume measurement, and that spits out your density. That's easy. There's a little bit of algebra, though, if we want to take that idea and do something a little bit more interesting with it and use density to convert, essentially, between mass and volume. So let's take a few minutes to kind of do that. We're going to work at the bottom of the page here. So if we wanted to use density in a different way, maybe to find mass, what we could do is we could take this equation where density, or D in this case, equals mass over volume, and we could solve it so that this density equation is being solved for mass. Now, how would we go about doing that? Well, to solve an equation for something like this m on top here, we need to have two things happen. We need it to be by itself on one side of the equal sign and be in the numerator. That's a common misconception, is that a lot of times students try to get it just by itself and get it by itself but in the denominator. That's really not solving for a variable. That's solving for the inverse, right? So just to kind of write a little side note here, right? Anytime we're trying to find a variable in algebra, we have two basic goals, and I just said them. We want the variable by itself, and we want the variable in the numerator. That's how we're going to do it. So let's switch back to my blue and come down and do some algebra. So we want to get mass by itself in the numerator. Right now, mass is being divided by volume. So if I multiply each side of my equation by volume, the volumes will cancel out. Let's go to a nice orange here on the right side, which means that volume times density is equal to mass. Right? That's solving that equation for mass. M is for mass. We could also take, right, so now before we move on, what does that mean, right? That means that if we can measure the volume of a substance and we know its density or its identity, right? Because density is intrinsic property, if we know our substance is, for example, aluminum, we know that the density is 2.7. If we know it's copper, it's whatever the density of copper is. I don't know it off the top of my head, but it's easy to look up, right? So what we're doing here is we're using our density equation to help us go from two things, from mass to volume, volume to mass, using density as a tool instead of just trying to solve for it, right? So this is how we solve for density equation for mass. Volume times density will equal mass. Now on the right of that line, we're going to switch colors here, and we're going to solve density for volume in kind of a lavender color. So when we're solving an equation, right, we're going to remember we're still working with our density equation up here in the pink box. So we should start back up at that point. Don't start over here. We're going to take density, which is mass over volume again. And now I want to get volume by itself. I want to solve the equation for volume. Remember, I should get the variable by itself, and I should get it in the numerator. I need to do both of those things to solve for volume. Well, right now, volume's in the denominator. So there's different ways to approach this algebra. Some people would like to cross multiply. Some people would get volume by itself, but in the denominator, and then move it around so it's in the numerator. When I look at this and I say, well, I need to get it in the numerator eventually anyway, why wouldn't that be my first step? So I'm going to move volume from the right to the left by actually doing the same thing I did in the mass solving, by multiplying each side by volume. When we do that, switch colors to make the point a little bit more obvious. Purple, pinkish would be good. The volumes will cancel out on the right, and now it's on the left. That's important because now it's on the left, but don't get confused by my little line here, just to emphasize. Volume is now on the left. It's not by itself, but it is in the numerator. So if we kind of stay persistent here, we will be able to, I'm working in lavender right now, get volume now by itself. So at the moment, we have volume times density equals mass. So now I'm going to divide each side by density. Density is going to cancel out on the left with itself. So what does that mean? We've canceled density out on the left. So we've gotten our volume, I'm going to write it over here, by itself on the left. And that will now be equal to mass divided by density. And you have now seen the density equation. You've solved it for mass, and we've solved it for volume. Just to summarize real quick, let's just write those three equations over on the side here. So we started the video off by talking about how density was equal to mass divided by volume, that it's a ratio, right, between these two objects, which means that it will scale up into different forms, and it'll always be a 2.7 for a specific ratio of mass to volume. In the case of aluminum, that'll always be 2.7 grams per every 1 centimeter cubed. But then we said, well, we can take this equation and do some more powerful things with it. We can solve it for mass and get mass equals volume times density, or we can solve it for volume and get volume equals mass divided by density. And that is the end of the video. Thank you.